proud to present the first speaker for this panel, Gilad Walden, the VP of Technology and Strategy of Forescout.
To be here and to talk after these honorable speakers. So what I want to share with you today is a research that we did at Forescout, aiming to develop a multi-stage malware prototype to compromise a building management system. So this falls very nicely into the rest of the topics that were discussed before me. So first, to set the stage, what makes a building smart? So I'd argue that the more information that you collect, either from the inside of the building or from the outside of the building, digitize that information, apply some analytics, and then closing the loop through automation and connectivity between the different systems that comprise a smart building, the smarter it is. Now, smart doesn't necessarily mean new. And even most of the enterprise buildings, public venues are of course already there. And still owners can enjoy the benefits of the new innovations that are introduced to the market and add them as an add-on on top of the existing infrastructure. So to move a step deeper, this is a typical depiction of a smart building topology from the network dimension. And you have different planes. So you have the field plane, where you'd find sensors and actuators that collect information from the building. Then you have the control and automation plane that has the logic of a certain system. And then the management plane that allows users to interact with these systems. And there are prevalent systems that you'd find in any building, like HVAC management, physical security, as well as video surveillance. Now, each system has different stacks and technologies. So you have, you'd hear names at the field level, protocols like BACnet and Modbus and their Ethernet equivalent protocols, as well as IT-centric protocols like HTTP, FTP, and many others. And overall, this can be a pretty hectic collection of new and old stacks in a single network, in a single location. So not surprisingly, and like any space that is becoming increasingly connected, we are seeing a major increase with the amount of vulnerabilities that are disclosed in devices and systems that are associated with building management systems. And also the complicated supply chain and ownership. In many cases, the owner of the system is not the one that, it's not the enterprise. It can be a third-party supplier, but still these systems are interacting with each other over the network. So there are different ownership models, but eventually over the wire, everything is connected. So we put ourselves in the shoes of the adversaries, and we worked along the lines of the Cyberkill Chain, collecting information from everything that was published by the community, any disclosure, researching the prevalent devices and systems and their architecture, and also doing a bit of our own hacking in order to compromise such a system. So we started by assembling a lab where we can have our hands dirty. And we've purchased some equipment, controllers, surveillance cameras, and other sensors, and assembled them together. And this is where we could do our experiments and come up with the plan. 60 days later, among other things, we've discovered 10 zero days in one of the most common access control controllers, as well as managed to fully compromise such a system. And I'll walk you through the journey that we've been through. So after the initial research, we came up with the attack plan. So we will be getting in from the internet through this surveillance subsystem that has a very wide footprint, and it has many devices that are internet-facing. And then we will move laterally through unsegmented parts of the network in order to compromise the control plane. So luckily for us, a vendor named Vidu, the startup that is based here, came up around the same time with severe vulnerabilities in one of the most common surveillance cameras brand. So we leveraged their work and we tweaked it a bit, and that allowed us to gain access to the network and take control of such an IP camera, which gave us the footprint that we needed and a pretty powerful Linux box that we used to move to the next stage. We went through the managed plane where you'd find workstations and desktops, so we leveraged some default credentials that are shipped with one of the applications that are used to manage these systems, as well as other known vulnerabilities, and moved on to the most interesting part, the control and automation plane, where you'd find programmable logic controllers and other non-standard equipment. And here we've thoroughly learned the architecture of one of the systems. It has a non-standard operating system called QNX. And this is where we've discovered a buffer overflow that allowed us to take control of one of the system daemons, enable an upload command that is by default turned off, and upload our malware through the web application that is shipped also with that controller. So from that point and on, we could completely control any door that was connected to that controller, open the door for illegitimate users, ad users, and do anything that we wanted throughout that compromise. Now, we also wanted to stay stealthy in that system, so we've explored a few persistency techniques, eliminated most of them because they were irrelevant for that specific operating system, and eventually chose a technique called path interception, where the controller actually rebooted our malware on each and every system boot. So that ended the actual part of that research, and when the team completed their work, they created the bill of materials. How many men and women hours we've spent in doing that research, the cost of the equipment. And as you can see here, this is not a skyrocketing cost. This can be pretty affordable for someone who would be interested to reuse the work that we did and to also commoditize that and use it with and sell it to many interested parties. So, to conclude, our objective was to collect, to learn these environments and to really analyze the attack surface and to be very, to base future ways to better secure these environments through knowledge and through real experimentation. Thank you very much.